Well, so here's another example of little higher difficulty level. Um, a cone is in the shape of an inverted, a funnel is in the shape of an inverted cone, which is 30 meters deep, and the diameter across the top is 20 centimeters. The liquid is flowing out of the funnel at a rate of 12 centimeter cube per second. At what rate the height of the liquid is changing at the instant when the funnel is 20 centimeters deep. So once again, I try to draw a diagram for this. So this is the funnel, assuming the according to the given condition. So this is the funnel, and the liquid is flowing out of the funnel at a rate of uh, um, that is 12 centimeter cube per second. So actually, if I look at this, is nothing but the volume. So dV by dt is actually given as the volume, and it is negative because it is the volume of this funnel is reducing by that amount every second. Now, if I first want to see what exactly we are relating here, we're relating the rate of change of height. So at instance, here the liquid is here, at instance when liquid is here, at instance when liquid is here, and at what rate this height is changing. That's what is the specific question about. So what I actually do out here is I'm just going to quickly uh, draw the top of this, let's say, a surface at one instance. And I take the liquid, let's say at that time, the radius is r, and the height of that liquid at that time is h. And as we know that in the beginning, the question has been given is that this is, let's say, this is 20 meters. The diameter is 20, diameter across the top is 20. So the radius is 10. And the depth is 30. So the depth of the big cone that is here to here is actually 30. So the net depth that we're talking about is given as 30. Now let's just try to see how we can get a relation um, for volume and the height. Now the most interesting question here is that as every time you go down, okay, every time you create the surface here, you look at the surface, what is happening is the radius and height both are changing. Now, actually, the volume of, let's say, any water cone that you see here is actually, it is 1/3 pi r square h. Now, since the radius and height is changing, I can't do much about this question until I apply some technique that by which I can find out this expression purely in terms of volume. Because they haven't mentioned at all anywhere the rate of change of radius. Rate of change of radius has not been given. So you can't straight away apply product rule. So what I do is I apply the concept of similarity to get my answers. So when you apply the concept of similarity, actually here, the first triangle that I look at is this one, the big one. This is the first triangle I look at. So this is my first triangle that I'm going to take similarity. And the second triangle that I look is this one, which is here to here. So these two triangles are actually similar. So what I'm going to do is I'm just going to take the ratio, that is 10 over let's say here the radius is equals to the total height, which is 30 over um, the 30 over the height. So we get a relation in the capital R and the small r. So here's this is the most important decider. So I just repeat again, I'm taking this big triangle, which is here, and then this small triangle, which is here. So 10 over r equals to 30 over height. So 30 over height. So if I just draw a separate diagram, you can just have a look at it. This is 10, this is r, this is 30, this is h. This tiny triangle is similar to the big triangle. And now from here, I can get radius in terms of height, which is radius is actually 10 over 30 times height. So which is radius is 1/3 in the height. Now I'm just going to write down this formula purely in terms of height. So I'm just going to replace the radius with 1/3 of height. So volume is 1/3 pi times h over 3 the whole square times h. And if you simplify this, it is pi h cubed over 27. So now this is the interesting and the most decider step if you want to get this problem correct or not. Now, after this, the procedure is simple. After this, you differentiate both the sides with respect to time. So it is pi over 27 times h cubed derivative is 3h square times dh by dt. So now since dv by dt has been given as negative 12, this is pi over 27. 3 times height has been given as 20 square times dh by dt. And then you can find out what's the value of dh by dt straight away. So dh by dt can be calculated, can be found out straight away. So this is how you do this question and this particular related rate problem. So here we go with the next example. All right, so in this example, what we have is that the sand is being dropped at a rate of 2 centimeter cube per second to form a conical shape. Now, the radius of this heap is increasing at 0.3 centimeters per second. And here the interesting thing is that they're asking at what the height is changing. So there are two rate of change given here. The first rate is the dv by dt has been given. And here the rate of change of radius has been given to you. And what is expected is that find the rate of change of height. So we basically got to do find out a relation that can link up all three things. Okay. So now first thing what we got is the volume is 1/3 pi r square h. Now for this example here, what we're going to do is we can straight away apply the related rates. So dv by dt will be the derivative of 1/3 pi is a constant, so keep it outside. The derivative of radius square. So first I'm applying product rule. So the derivative of radius square is 2 times radius times dr by dt into height plus radius square times dh by dt. So this is the product rule I applied. So the derivative of r square first is I did u v dash plus vu dash. So u is 2r, the u is r square if I take the derivative of r square is 2r dr by dt and times height, I didn't touch it, plus a radius square times dh by dt. So this was the main crucial step here, since the derivative of height with respect to time is just dh by dt. And then it's just about substituting the values. So dv by dt here will be 1/3 pi times 2 times radius is 3 times dr by dt, which is 0.3 times h is 5 plus 3 square times dh by dt. And then dh by dt has been given, I mean, they're asking us to find out. dv by dt is given as 2. So you can find out the height, rate of change of height, which comes out to be. So this comes out to be, so dh by dt from here is minus 0.79 centimeters per second. So this is how you basically do the related rates when both the variables are changing.